Today we're going to look at Pythagoras' theorem. The side opposite the right angle in a right angled triangle is called the hypotenuse, and it's always the longest side. So if we look at this right angled triangle here, the longest side here, it's opposite the right angle. So here's the right angle, it's opposite the right angle. This side is called the hypotenuse. And Pythagoras' theorem states that the sum of the squares of the two shortest sides in a right angled triangle is the same as the square of the hypotenuse. So, what this means is, if I was to take the square of this side length and the square of this side length and add them together, find the sum, then that would be the same as this length squared. So that can be expressed as an equation that says c squared is equal to a squared plus b squared. So this length squared is the same as this length squared plus this length squared. That's Pythagoras' theorem. Lengths can be expressed with exact values using these things called surds. Some examples of surds are square root of 2, square root of 28, or 2 times the square root of 3. Now each of these different values can't be, they can be rounded, but they can't be simplified any further. They can't be turned into just one number. The surd part is using our square root to express this as an exact value. So these values are irrational. Just like pi is irrational, it can't be expressed as a fraction. It's a non-repeating decimal that goes on forever. So, for example, the square root of 2 is equal to 1.4142136, but it keeps going on and on and on, and it never repeats. So this value here can't be expressed as a fraction. This can be rounded, so we can say that the square root of 2 is approximately 1.41, but it cannot be expressed as a fraction. So these exact values could come up. For example, if I was to have a right angled triangle with our lengths of A and B as 1, and I wanted to determine what the hypotenuse length was, C. We know that C squared is equal to A squared plus B squared. So that would be 1 plus 1. So that means that C would be the square root of 2. So C is approximately 1.41, but as an exact value, the length of C is square root of 2 or root 2. If we have a look at an example here, it says find the length of the hypotenuse in the following triangles. Round to 2 decimal places in part B, this part here, and give the exact value for part C. So let's have a look at A first. Our lengths of A and B are 5 and 12. So we need to make sure, if we've got a formula, if we've got a theorem or something, we need to make sure we state that first if we're going to use that theorem. So I've written down Pythagoras' theorem here. C squared equals A squared plus B squared, and then substituted in values for A and B. 5 squared is 25, and 12 squared is 144. Adding those together, I get 169. So to find the value of C, I need to take the square root of both sides. So taking the square root of 169, I get 13. So our length here of the hypotenuse is 13. For part B here, writing down Pythagoras' theorem again, substituting in our values for A and B. Now it doesn't matter which value for A or B, which value we use for A and which value we use for B. The only value that matters that we differentiate is our hypotenuse. The hypotenuse is always that side length that is the longest side and is opposite the right angle in our right angle triangle. So if we take 9.5 squared and add 7 squared together, we get 139.25. And the square root of 139.25, if we round it to 2 decimal places, is 11.80. For our last one here, we need to express it as an exact value. So we've written down Pythagoras' theorem, substituted in our values for A and B, 2 and 5. 2 squared is 4, 5 squared is 25, so that means adding those together, summing them, is equal to 29. Taking the square root of both sides to find just C by itself and not C squared is going to be root 29, and this is our exact value. It's a surd, the square root of 29, it's irrational, it can't be expressed as a fraction, It could be rounded. We could round the square root of 29, but this is the exact value. If we've been asked to express it as the exact value, we leave it like that.